So let's see the marvel of moles, the stoichiometric coefficient. These are the superheroes of the chemical reaction. In a chemical reaction, they represent the number of moles of substance involved in the reaction. If you don't understand, let's see this reaction. Hydrogen and oxygen reacts form water. Here, the number 2 before the hydrogen and water are the stoichiometric coefficients. They mean that for every 2 moles of hydrogen, we need 1 mole of oxygen to save the day and form 2 moles of water. So I have more examples here. Ammonia. Look at the cool recipe for making ammonia NH3, which is an important ingredient in fertilizers. Our reaction is nitrogen and hydrogen forms ammonia. So the stoichiometric ratio of N2 to H2 to NH3 is 1 to 3 to 2. Imagine like making chocolate milk. For every scoop of cocoa powder, you need 3 cups of milk to make 2 delicious cups of chocolate milk. Ammonia. If you start with 2 scoops of cocoa powder, you need 6 cups of milk because the ratio is 1 to 3. And you will end up with 4 cups of chocolate because the ratio of nitrogen to ammonia is 1 to 2. So 2 cocoa powder will form 4 chocolate milk or 4 moles of NH3. Another example is cooking up carbon dioxide. Now let's look at the reaction. See every day. The, the methane, which is the main component of natural gas, burns with oxygen to form carbon dioxide and water. The ratio is 1 to 2 to 1 to 2. Think it of as popping popcorn. Every kernel of CH4, you need 2 spoons of oil to form 1 popped corn and 2 bits of steam water. So if you start with 5 CH4, you would get what do you need? How many spoons of oil you need? You need 10 because the ratio is 1 to 2, so 5 gets you 10. And you will end up with 5 moles of CO2 because the ratio of CH4 to CO2 is 1 to 1. So if you used 5 CH4, you'll get 5 CO2. And 10 bits of steam of water because the ratio is 1 to 2. So for 5 CH4, you will get 10 H2O. Remember, it's like just cooking or baking. Practicing stoichiometry can be fun. So think of it as the ultimate balancing act. In chemistry, it tells us about the quantitative relationships between the reactants and products in a chemical reaction. Imagine it as a scale of justice. On one side, you have reactants, on the other, the products. Stoichiometry ensures that the balance of perfectly using the law of conservation of mass. So let's see stoichiometric issues the recipe of reaction. Like a recipe for chemical reaction, our previous reaction water and is formed by hydrogen and oxygen. Stoichiometric ratio was 2 to 1 to 2. It's like balancing a cake. For every 2 cups of flour, you need 1 cup of sugar to make 2 delicious cakes. So moles and more moles practical scenarios. Let's dive into some fun scenarios. If we have 4 moles of hydrogen, we would need 2 moles of oxygen and to produce water. It's like doubling the cake recipe. And if we triple it, 3 moles of hydrogen, you will need how many moles of water? Formed, so 2 formed 2, so 3 will form 3 again, provided we have enough oxygen. What about mass and the moles, the conversion dance? Don't forget we can dance between mass and moles. If we have 2 grams of hydrogen, imagine 2 tiny bags of flour and enough oxygen, it would be produce 36 grams of water. So instead of writing your ratios as moles, you can write them as grams. We have learned what is the relationship between the grams and moles through the molar mass. So every time you have moles, you can change it into mass, and if you have mass, you can change it into moles. Remember your law, the number of moles is equal to mass divided by the molar mass. Remember, chemistry is all about having fun while learning, so enjoy the journey.